Okay, Pythagorean theorem, it's an oldie but goldie. Given a right triangle, and triangle with a 90-degree angle here, with the two short sides A and B and the diagonal C, then A squared plus B squared equals C squared. Uh, oh, oh dear. I wish I had, in the old days, I would stop at this point and show a little diagram which explains why this should be so. I'll let that be. Okay, so A squared plus B squared equals C squared. So we can solve for C by taking a square root. C equals root A squared plus B squared. We can solve for A by subtracting B squared and then taking a square root. So A equals root of C squared minus B squared. Likewise for B, we subtract an A squared and then a square root, and B equals root of C squared minus A squared. So here these are. And this ties into distances in Cartesian coordinates. Having this point at coordinates x1 by y1, this point at coordinates x2 by y2, then you draw this line horizontal, this horizontal line and this vertical line. This line equals its length is the difference in the x values, x2 minus x1. This line equals its length is the difference in the y values, y2 minus y1. And so by Pythagoras, d equals square root of the sum of x2 minus x1 all squared plus y2 minus y1 all squared. This is the distance formula for points in the plane. I note that this is 4 ofs d. D equals the square root of the sum of the squares of the differences of coordinates. Whew. All right, here we go. If we have, here's a triangle, right triangle. Length A is 6 feet, length B is 8 feet. What's C? Well, simple enough. C is root of 6 squared plus 8 squared, which is root of 36 plus 80 plus 64, which is root of 100, which is 10. So C is 10 feet. If A is 8 feet and B is 15 feet, what's C? C is root of A squared plus 15 squared, which is root of 64 plus 225, which is root of 289, which is 17. C is 17 feet. Now here we have B and C, and we want to find A. B is 9 feet, C is 41 feet. And to find A, we need to use the square root of C squared minus B squared. So that'll be A is root of 41 squared minus 9 squared. That's root of 1681 minus 81, which is root 1600, which is 40. So A is 40 feet. If we have a triangle here, which is an isosceles right triangle, these two lengths are equal, 3.2 feet. What's the D? The diagonal. D is root of 3 plus 2 squared plus 3.2 squared, excuse me, which is 3.2 squared times 1 plus 1. In other words, 2. So we break this root apart into root of 3.2 squared times root of 2. So 3.2 root 2. So that's the distance, approximately 4.525 feet. Now here we have to find the distance between 6 by 8 and 12 by 16. So distance. Well, difference of the x's is 6 minus 12. That goes here. Difference of the y's is 8 minus 16. That goes here. So those differences squared, summed, and rooted. 6 minus 12 squared is negative 6 squared. 8 minus 16 squared is negative 8 squared, square root. Negative 6 squared is 36. Negative 8 squared is 64. Root of 36 plus 64, which is root 100, which is 10. So the distance between these points is 10. What is the distance between negative 2 by 1 and 3 by 4? Well, root of sum of squares of differences. Negative 2 minus 3 in here, squared, plus 1 minus 4 in here, squared, all rooted. So this is negative 5 squared plus negative 3 squared, square rooted. Negative 5 squared is 25, negative 3 squared is 9. Add them up, get root of 34. That's the distance, root 34. What's the distance between negative 2 by negative 1, negative 1 by negative 5 by 8? Well, again, negative 2 minus negative 5 here, squared, plus negative 1 minus 8 squared here, add and square root. Negative 2 minus negative 5 is negative 2 plus 5, which is 3. Square that. -1 minus 8 is -9. Square that. 3 squared is 9. 9 squared is 81. Square root of that sum. Root 90. Okay, the largest square factor of 90 is 9. So you get root 9, root 10. Root 9 is 3. 3 root 10 is the distance. Now, okay, for this one, we have a box 24 inches by 24 inches by 4 inches. Can a 34-inch femur fit into this box? Presumably at a diagonal from one corner to the opposite corner. Now, all right, here we have to do a three-dimensional version of Pythagoras. So we have a box which is A along here and B along here and C up. And the diagonal between opposite sides is square root of sum of squares of all three things. A squared plus B squared plus C squared square root. So here we go. Distance will be 4 squared plus 24 squared plus 24 squared square root, 1168 root, about 34.168 inches. So the distance from opposite corners is just a little bit bigger than 34 inches. So presumably it can. However, I'm a little skeptical because that's not much bigger. And presumably a femur has some thickness to it, so it might poke out of the box. I'm not sure about that. And anyhow, I wouldn't advise sending something potentially as fragile as a femur. I assume a fossil femur tilting because there'd be air between it and the bottom of the box. And I wouldn't trust it, but whatever. So there's that. Okay, I think we've done this.